Hello, good afternoon. My name is Noah Philip Ibay,
And I am Chris Martin Oliveros.
and we are presenting the topic of function declaration and definition, recursion, and math functions. Our objectives for today is to learn how function declaration and definition works, to learn how function recursions work, and to learn how math functions work. Starting off with function declaration and definition. Function declaration is the process of specifying the name, return type, and parameters of a function without defining its implementation. It serves as a prototype or blueprint for the function, informing the compiler or interpreter about its existence and signature within the program. For function definition, it involves providing the implementation or body of the function, including the actual code that executes when the function is called. It defines the behavior and functionality of the function, detailing how it processes input parameters and returns output based on the specific logic.
Oh,
For the examples on the left, we can see that we have function declaration, which we have void my function for its example. On the main method, we have int main followed by my function, where in this line we call the function itself and then putting in return 0. For the function definition, here we have void my function with the inside printf and I just got executed. Now, what it does, it prints out the message using printf um, by calling the function which we have declarated itself on the first, which is called void my function. Now, when we apply this example to the right, in which we declare our function first, we have int add, and then we have int a and int b. For for the main method, this is where we declare a variable called result to hold the output of the add function. For the function calling, we add the add function with the values of any value. In this case, we have an example of the values 5 and 3. And this means that we are asking the program to add 5 and 3 together, which you can see here, printf, the sum is percentage %d slash n, and then the result. And the last one, we have the function definition, which is also int add, int a, and int b, same as the function declaration, but now we add return a plus b, in which it takes the two numbers a and b. So for example, int a is 5 and int b is 3, and then it returns their sum. So in which you can see here in the compiled console window, the sum is 8.
so moving on to the function recursions. In computer science, recursion is a method of solving a computational problem where the solution depends on solutions to smaller instances of the same problem. Recursion solves such recursive problems by using functions that call themselves from within their own code. So, so as you can see in this example, uh, we have here is the recursive function, but we use we will use the recursive function to calculate factorial. The recursive function is the recursion it is a process where a function calls itself. In other words, a function calls its own code repeatedly until it reaches a certain condition. So our condition here is the if is this function, the recursive function. If n is equals to 0 or n is equals to 1, this is our condition. Else we'll we'll use the return n times factorial n minus 1, which is our formula for which is the formula for factorial. So in our main code, the we, de- we declare that int num is equals to 5. So the factorial of 5 is 120. Notes to function recursions. The developer should be very careful. The developer should be very careful with recursion, as it can be quite easy to slip into writing a function which never terminates, or one that uses excess amounts of memory or processor power. However, when written correctly, recursion can be a very efficient and mathematically elegant approach to programming. So moving on to the math functions. C math functions form an integral part of programming in the C language, providing a variety of mathematical operations for developers to use. C math functions can be classified into two main categories: the basic math functions and advanced math functions. In addition to these main categories, there are also a number of utility functions that are used for specific application. To use them, you must include the math.h header file in your program. The basic math functions in C are those that perform elementary mathematical operations such as the addition, subtraction, multiplication, division, and the modulus. Some include the absolute, which returns the absolute value of integer. The float absolute returns the absolute value of an integer but in float. Then the ceiling rounds up a floating point number to the nearest integer. Ito yung 2 point if the decimal number after the after the whole integer is zero point 0.5 above, then we'll round it up to the we'll round up from 2.5 to 3, and then the floor, which is the rounds down a floating point number to the nearest integer, where if the decimal point is zero point 0.4 below, then we'll round it up to just 2. Then the power raises a number to the power of another number, and the square root, where it will calculate the square root of a number. These functions can handle most simpler arithmetic operations in your program. So here is the advanced math functions. The advanced math function in C are more complex and cater to specific mathematical needs, such as the trigonometric, the logarithmic, and exponential operations. Some examples include the sine, cos, and tan to calculate the trigonometric sine, cosine, and the tangent, the a sine, a cos, and a tan to calculate the inverse trigonometric sine, cosine, and tangent, where and then the exponential to calculate the exponential value of a number, the natural log, and the base 10 log, no? Right? To calculate the natural and base 10 logarithmics. The the hypotenuse calculates the square root of the sum of the squares of two numbers useful in calculating the hypotenuse of a right angle right angled triangle. So so here are the example of basic math functions. We use the double variable for both of the example because it has the much more bigger bytes to use. Double x is equals to 2.5, and double y is equals to negative 4.7. However, we will find the square root of the x. To find it, we use the square root of the point to f per point to f percent point to f is percent point to f. So square root of 2.50 is 1 point. 58 as we use the square root functions to find the square root, and we use the fabs, the float absolute to find the absolute value of the of negative 4.70, and the the expo the exponent e raised to the power of 2.50 is 12.18. And then the next one,
Moving on to the example of advanced math functions. For the int main function, we have declared a two values, which are double x is equals to 2.0 and double y, which is equals to 3.0. For the first example, we are showing the power function. So for example, we have the power of this number, which is equals to float, raised to this number is equal to this number. Now, to the right of it, we have three parameters. X, the first parameter is equals to 2.0, and the next parameter, which is y, is equals to 3.0, and then the next parameter, which is the power function, but with x and y inside of it. Now, what this does is that we we have the first value, which is x, so the power of 2, and then it will be raised by the next uh, variable, which is y, so which is equivalent to 3.0. So it will be power of 2 is raised to 3, and the end result of that is 8. Now to the next line, or the next example rather, we have the ceiling function. In this case, we have the ceiling of this number is equal to this number. And the parameters to the right, we have x and ceiling of x. We all know that the um, x value is equals to 2.0, and then we can now translate the ceiling of x into ceiling of 2.0. Since the ceiling function requires us to round up a floating point number to the nearest integer, we do that by rounding up 2.0. So in this case, the output of the ceiling function is ceiling of 2.0 is equals to 2.0, since 2.0 is near 2. And for the next line, or the next example rather, we have the floor function. Floor of this number is equals to this number. We also have the parameters x, which is equivalent to 2.0, and then the floor of x. In this case, you can substitute x for 2.0, which will now translate into floor 2.0. Since the floor functions requires us to round down a floating point number to the nearest integer, the output is now floor of 2.0 is 2, which is also similar with the ceiling function, or rather similar to the answer of the ceiling function. And lastly, for the last example, we have the natural logarithm of this number is equals to this number. And then the parameters to the right are x and the logarithm of x. So the first parameter is x, which is equals to 2.0, and then the logarithm of x. So basically what logarithm of x does, this function calculates the natural logarithm, which is the base e logarithm of a given number of x. So our given number here is 2.0, so we can translate that into logarithm of 2.0. Since the natural logarithm is the logarithm to the base e, where e is approximately equal to 2.71828, it it means that in simple terms, we have a number x, which is 2.0, and then logarithm of x tells us which power e, or Euler's number, must be raised to get x. So in this example, the logarithm of e is 1 because e is raised to the power of 1 is e. But here in our example, we have the logarithm of 2. So now our output, or the result, is now the natural logarithm of 2 is 0.69.
So that is all for our report for our topic, which are the function declaration, definition, the recursions, and the map function. So that is all. Thank you.